My name is Pierre. I work in web search.
And I'm Ilya. I'm a developer advocate with the Chrome team.
We're here today to talk to you about why HTTPS matters, and we want to convince you that all communication should be secure by default. I know there may be some skeptics here. We're going to talk about the motivation to explain to you why that's the case. We're going to talk to you about some common questions and misconceptions that we've seen, and we're going to give you some hands-on tips and best practices about how to go about doing that.
So, Pierre, I'm glad that you mentioned the skeptics, because I think most of us will agree that secure by default and HTTPS matters for things like e-commerce and banking. But I think what we're saying here is actually much, much stronger, right? There's a reason why the title of our talk is HTTPS everywhere, and that is we should be using secure by default communication for all communication everywhere. And that includes my playlists, the news articles I read and where I read them, and all other things that I do online. Because while it seems like individually the metadata that is available that you can gather by looking at these unencrypted sites is benign, when you actually put it all together, it reveals a lot about my intent and can actually compromise my privacy.
So that's actually a very interesting point. I see my website there. I didn't ask for this, by the way. And I write about tech news stuff. It doesn't sound like sensitive. Does that mean I really need to encrypt it too?
Well, I think you know my answer. The answer is yes, and there are actually two reasons for that. The first reason is you want to protect the privacy of the visitors coming to your site. So as we said, it's not just your site, it's also other sites. And second is you want to protect your site as well. So all of us are developers here. We're building sites and services, and we want to make sure that we don't give out access to malicious participants. For example, you maybe have an admin section of your site, or you want to make sure that your service is not compromised by a malicious attacker. So when we talk about security, we actually mean three specific things. We're talking about authentication, data integrity, and encryption. Authentication makes sure that the servers that we are talking to are who they claim to be. So for example, if you're talking to your bank, you want to make sure that you're talking to the right entity. Data integrity means that the data is not modified while it's in transit between your client and the servers. And encryption, of course, protects the actual communication from eavesdroppers such that they can't figure out what's going on here.
And this is actually an important point, because when I'm talking with people, when we say HTTPS, people immediately think it's only about encryption. But in reality, you need all three. They're equally critical. Because just to give you a simple example, is that you can actually have an encrypted channel to an attacker. And you wouldn't know any better, and that's not actually protecting you. That's why authentication and data integrity kick in, and all three of them are what form a secure website.
Right. So the good news is this is actually all taken care of for us by transport layer security. So for those that are not familiar, transport layer security is a protocol. And when we talk about HTTPS, we actually are just talking about HTTP running on top of TLS. And of course, TLS is actually used for a variety of other applications as well. For example, the Gmail team uses TLS to secure mail delivery. But in this particular session, we're going to focus on HTTPS and on the web in particular. So I think a lot of this sounds very abstract, authentication, data integrity, and other things. So let's actually take a look at a hands-on example. So we've been scheming this kind of crazy idea. We want to launch a new service, tasktip.com, where you can come and create guides and find guides for everyday things. Anything from how do I make a great omelet to how do I configure my Wi-Fi router. So let's actually step through the exact steps of how we would make it secure by default.
So before we get into this, like tasktip.com, what we're saying, one of the things, motivating examples we had is that we're going to tell people how to make a good omelet. And that doesn't sound that sensitive. So I want to go back like what we said earlier. Like, do we need to bother with HTTPS here?
Well, once again, I think you know my answer. But I'm curious, what do you guys think? Show of hands, how many people think that we should encrypt and deliver all of the content via HTTPS? All right, so there's definitely some skeptics here. So let's work through some examples and see how things can go wrong. So first of all, Pierre, I know that you're coming from the London office, so you're probably a little bit jet-lagged. You came here for I/O, and I'm guessing you had to pay a couple of visits to your local coffee shop.
That's true, yes.
OK. You're also coming from London, which tells me that you probably have roaming charges on your phone. And let's face it, those are pretty high still. So you're probably pretty happy to use their Wi-Fi as well.
That's true, too, yes.
OK. Well, when you use unauthenticated Wi-Fi or unsecure Wi-Fi, passive attackers can actually just listen in and gather data about what you're doing. So they can see which sites you're browsing to, what you're doing, how much time you're spending on each article, and that includes all guides on tasktip.com. So that's a problem. So the combination of all of these signals actually reveals quite a bit about what you're up to. And that's kind of scary, isn't it?
Yes, that is very scary. But the other thing is that the key point is what Eli was saying, is that any individual visit is not interesting on its own. It's when you start looking at, in aggregate, about all the behavior that somebody eavesdropping on that insecure connection, that you can start to build a bigger picture and a better idea about what that person is doing. And this is why you need to secure everything, because you don't want to be part of that pile of information that your users are inadvertently showing to the world.
Right. So as owners of, owners of the tasktip.com site, we want to protect the data of our visitors, right, to protect them. But also as good citizens of the web, we want to make sure that the web is getting better, it's getting more secure. So that's a good thing too. Now, compare this scenario if we had HTTPS deployed on all of the sites. So instead, when you're using this public Wi-Fi, all of the communication would be done over encrypted channels with each of the servers. So the attacker couldn't just listen in and figure out what we're up to. So this sort of passive attack where you just kind of take a seat back and just listen to what's happening is basically impossible, which makes the web more secure. Now, this is great, right? This protects our users. But HTTPS also provides important features for us as site owners to protect our site. So let's talk about another example. Instead of just being a passive attacker and just listening on what's happening, an attacker can actually target your site, right? So perhaps you have a particular user that the attacker is interested in. They could actually trick the user into visiting a site that is hosted by them, at which point all bets are off as to what they could do.
Yes, and this is actually quite scary. If somebody's actively attacking your users like that, what that means is that they get to change every single bit about your website, and you wouldn't know any better. They could change, the text. They can steal passwords. They can do whatever they want.
Right, and that's why we have server authentication. So when you install an HTTPS certificate, what you're actually doing is you're providing a guarantee that when the client actually connects to your server, they are talking to the right server, right? So somebody else can't come along. They can get your public certificate, but they don't have your private key. So when they can't complete that handshake. And that is why when you get that green lock icon in your browser, that you get that warm, fuzzy feeling because you know you're talking to the right entity.
Yes.
So that's very important.
And this is why we have certificates, because they add this extra authentication that you know who you're talking to, and your users would know if something is wrong, if somebody's trying to actively intercept their connection.
Right, and that's why we need the 3 properties that we mentioned earlier, right? It's not just encryption. So as a summary here, TLS provides 3 important properties. First of all, attackers can't listen in because we're encrypting the data that's in flight. The attackers can't tamper with the data because we're checksumming all the data as it's being transferred. And the attackers can't impersonate the site or service. And they can't use our site as an attack vector against our site and our users as well.
So I'm convinced we're going to make tasktip.com to be completely encrypted. What we'd like to do now is to look at some practical tips about how to go about doing that. Between Ilya and I, when we talked with developers and webmasters, we've seen a pattern about what kind of questions people ask and what kind of concerns we have. And so what we've seen is this uncertainty, and people are afraid. In reality, once you know what you need to do, it's actually quite simple. So to help you think through these things, we've come up with this list of tips about what you need to be doing. We've broken it into 2 parts. One is about the operational stuff. How do you buy a certificate? How do you set it up on your website? And the other one is that most content right now is not secure on the web. So how do you migrate to a secure website? Eli's going to talk about the operational stuff. I'm going to talk about how you make it HTTPS friendly and how do you migrate there. And I'm also going to talk about how you make sure that Google's algorithms will index that and show it in search results so that you don't lose any search referred traffic.
Right. So this actually is a fairly simple process once you know what you're doing, right? So we're going to give you some checklists that you can follow along later and make your site be secure by default. So here's my sysadmin checklist. We'll go through these step by step, so don't worry about writing them down. I think the most important takeaway about this particular checklist is that you should actually follow it in order. The biggest mistake I find is that people just skip a step. So for example, they get the certificate, but then they don't really verify their server configuration. They're just going to drop it in and let it go. Or they do the verification, but they forgot to test for performance and other things. So go in order. But having said that, let's start at the beginning. So first things first, you should be using 2048-bit certificates. If you already have HTTPS on your site and you're using a 1024-bit certificate, that is no longer strong enough, so please upgrade and get a new certificate. And speaking of getting new certificates, perhaps the biggest and the first question that I get is, well, what about cost? Are these things super, super expensive? And the answer is, it depends on your use case. If you have a non-commercial use case, for example, I run a personal tech blog, that's a non-commercial site, you can actually get a free TLS certificate from a number of different providers. If you have an open source project, you can also get a free certificate from a variety of providers. Use your favorite search engine to look for those, and you'll find them. Now, if you have a commercial use case, then you need to think about what type of certificate you actually need for your site.
And that's actually something that I've always been confused about. How do I know which one do I need? And so, can you help with that?
Right, so it's actually pretty simple. The single host certificate is the cheapest one, and it's exactly as it sounds. You have a fairly simple site where all of your content resides at example.com, for example, right? And you serve all of your content from there, and that's all you need. Then you need a single host certificate. That'll cost you 10 bucks, and you're off to the races. Now, if you have a slightly more advanced use case where, for example, you have the site localized, you have a .com and a .co.uk, or maybe you have a couple of subdomains because you're using a CDN to serve your content, you will need a multi-domain certificate, or the multi-domain is probably the best one that you should use. And the key observation here is that you know all of the subdomains, right? So you can list them out, and you can get a certificate that will cover multiple domains. And then finally, the wildcard warrant is definitely an advanced use case where you perhaps don't know all of the subdomains or all of the origins that you will need. And that one can be quite a bit more expensive, so it's up and north of $100. But basically, it's not that bad.
Yeah, and that's the thing. It's not that bad for the most common use cases that most of developers here would face. And the amounts we're talking about money-wise are not that expensive.
Right, so somewhere between $10 and $30, and you should be, even for a commercial site, you should be up and running. So that's step number one. Once you got your certificate, you need to configure your server. And let's be honest, for somebody who has not spent a lot of time kind of looking and getting familiarized with all the options, it can be a little bit daunting because first of all, let's face it, the security can be complicated. As an example, this cryptic string here is actually the recommended cipher suite list that your server should be advertising as of today. That's the recommended list today. But please don't try and write it down because the biggest problem that I find is that a lot of developers try to piece together their configuration from a variety of different sources. Some of them may be outdated, some of them are maybe are not recommending the best things. So instead, please go to one canonical source that is up to date and use that as a starting point. And the good news is there is such a destination. The Mozilla guys actually have a great wiki page which they keep up to date with all of the best practices, and that includes configuration tips for all of the most popular servers. So if you just follow that link, that's a great place to get started. So, yeah.
I'm glad you didn't read this, by the way. So it's still a bit scary, but how do I know that I've done it correctly? How do I know that I've actually followed the Mozilla recommendations correctly?
Right. So once you've enabled all the 55 flags and configured your cipher suite and all the rest, right, I have the same question. And the tool that I use, that I like to use and recommend that you guys try is the Qualys SSL Labs test. So they actually provide a service where you can go in and type in the name of your site or the IP address of your server, and they will scan the server, verify, they'll run a whole battery of tests and verify all the latest settings, all the recommendations, and all the rest. They'll give you a score, and they'll give you hands-on tips for things like, hey, we found this problem, you should look into this. So this is a great tool to use anytime you update your server configuration. Anytime you change it, please use this tool.
Yeah, so this is a very nice tool, by the way. You can use it to test any website. So for example, if you're trying to buy from a website and you're not sure that security is that great, you can use it to test that. Also, you can use it to test your own server and see what you've done. And because it tells you what you're missing or things that could be improved, you can know what you can go about doing next.
Right, that's actually a great point, right? So we're talking about configuring your own server, but of course you can use this tool and other similar tools to also test your favorite sites. And perhaps, if you find an issue, talk to them, send a bug, get them to fix it. So next, once you've got your server configured, the next question I get is, well, what about the CPU resources on the server? I heard that all this cryptography work adds a lot of overhead and all other stuff. So the thing to recognize here is there are two steps to establishing the TLS tunnel. There is the asymmetric cryptography, which is the step where we verified the certificate and do the public crypto. And then there's the symmetric cryptography, which is where we encrypt, or where and how we encrypt the actual application data. The first part is the expensive part. And as Jacob points out here, it is very important that you leverage things like keep alives and session resumption to optimize for the step. So keep alives allow you to reuse the same connection between different requests, which means that you will only need to do that handshake once, and then the actual overhead is much, much less. And session resumption actually means that we can reuse the negotiated parameters of our secure session from a previous session when we establish a new one. So once again, we can skip that handshake and significantly reduce the overhead. So as you can see, the experience at Twitter is that it basically added negligible CPU overhead when they deployed it correctly. And the emphasis, of course, is on correctly.
Correctly, exactly, yeah.
So after that, the next question is, well, OK, great. But I'm still not convinced because there's a bunch of vendors, and there's a lot of literature that I've read about things like dedicated hardware and TLS offloading and all of this other stuff. And the answer there is, it is true that about a decade ago, these handshakes were so expensive that we actually needed extra and dedicated hardware that you had to buy. That is no longer the case. Modern CPUs are well optimized for the kinds of work that we do in the TLS stack, such that Facebook, Google, Twitter, and others all run TLS purely in software without any specialized hardware. This is all just commodity hardware, and that should work for you guys as well.
So that makes things easier. Basically, get a 2048-bit certificate, configure and test your servers, and you get to use the commodity hardware that you're already using now anyway. Anything else?
Right. So yes, there is actually. And one of the most exciting things to me personally that's happened in the last couple of years is the development of protocols like SPDY and HTTP2. So for those that are not familiar with SPDY and HTTP2, it's a new initiative to address some of the performance bottlenecks in the existing HTTP 1.1 protocol. And when we enable SPDY, so first of all, it turns out that you need TLS in practice to deploy these new protocols for a variety of reasons. But once you have TLS, this is just basically a config flag away. Most of the popular servers, Apache, Nginx, Jetty, all support SPDY. This is something you can enable. And you can see some numbers here. This is data for some of the most popular Google services after they've enabled SPDY. And this is compared to HTTPS. So we're making the performance much, much better for the actual page load time by enabling these things. So that's pretty awesome. But it's not just making performance better for the users who are visiting the site and improving the page load time. It's actually also improving performance on the server. Because one of the key features of SPDY and HTTP2 is that its goal is actually to use a single connection instead of having many connections open to the server. And by having a single connection, it means that there are fewer handshakes, there are fewer sockets, there are fewer buffers that we need to allocate, and all of that means that we consume less amount of memory, CPU usage, and other things on the server. So for example, in this study, this was actually done with mod SPDY and Apache. There was a server workload that was run comparing HTTPS and SPDY, and they found that when they ran it over SPDY, because there was fewer connections, the load on the server was actually much less, because we're just much more efficient about reusing this stuff. So truth of the matter is, enabling TLS and SPDY may actually decrease your ops costs, which by itself is a really nice selling point.
Yeah, exactly. Just do it.
Yeah. So as a quick summary, right, certificates are not that expensive. It really depends on your use case, so make sure you pick the right use case. Don't just assume that you need to get the most expensive certificate out there. You don't really benefit from that. There are great tools that will help you verify your configuration. I mentioned Qualys. There's a bunch of others. They're all very good. You don't need dedicated hardware, and there's a lot of optimization that you can do to optimize your stack. Now, unfortunately, we don't have the full day that we really need to kind of really go into the details as to how to tweak and optimize each and every bit. But I've put together a site, istlsfastyet.com. By the way, the answer is yes. And you can go there, and you can just follow the links to learn more about how to configure your servers. So if you're a sysadmin, or if you need to talk to your sysadmin, point them to that resource, and hopefully it'll help you to make it fast.
Right. So assume you've figured out everything you need to do on the server. How do you make HTTPS friendly for both your visitors and for search engines? There are a lot of misconceptions in this space, and I hope I'm going to clear up quite a few of them. So the first one I want to start with is actually the most basic one. We don't treat currently HTTPS sites any differently in search. They get indexed and ranked like any other website. Okay? But what we've seen is that the webmasters can break websites, the websites, the secure websites, in many different ways. Doing it right is easy, and I'm going to show you how to do it now. The general pattern of breakages that we've seen is that the indexing signals that we see on the website, both technically on the pages and in the servers, they are inconsistent, okay? So the one thing you need to do to make your servers, to make your websites be indexed correctly as secure websites, make sure that all the signals you are sending us are consistent, and all of them point to the fact that you want the secure website to be indexed. Now, a lot of the signals that we talk about, you're going to be doing them for your users anyway. So let's talk about them in detail. This is the checklist. It's actually very simple. This is roughly in the order that you need to do it anyway. The first thing is that you set it up on your server correctly. And then you set up all the signals in terms of like, we'll talk about these in a second, about the page resources like JavaScript and CSS, how you link to other content on your website, fix those up. Then you give us some signals that are not visible directly to the user, but our algorithms will help them decide and pick the right one. And once you have it all done, we'll talk about how webmaster tools can actually help you to figure out, like, keep monitoring that everything is humming along nicely, and also some error reporting that we see there. So first things first, make sure that the certificate is not broken. Now, what do we mean by that? There are quite a few ways they can break. The most common one is that we see that the server returns the incorrect hostname for the certificate. There's a mismatch, okay? So verify that the server is not doing that. Verify that what you're trying to secure is actually what is claimed to be wanting to secure. The other thing is that we've seen that the certificate itself has an incomplete certificate chain, okay? Don't do that. The way you do it, when I set up HTTPS on my website, where I bought the certificate made it very easy to actually tell me, like, this is the certificate chain that you need to do. The other one is that certificates expire. When you buy a certificate, it's actually for a certain period of time. One of the things that we see is that people forget to renew them. So here's a tip. Put it in your calendar a week in advance so you can renew your certificate before it expires, so you get the continuity. And the other thing is that keep an eye on webmaster tools, because we do try to send you a message when we see a problem in these. Like, if the certificate expired or there's a mismatch in the host name with the certificate, we try to alert you for these. So we'll talk a little bit more about webmaster tools, right?
And tools like Qualys would actually catch some of those as well.
Exactly,
so
yeah.
Please use that.
So the first thing is that this example is JavaScript, but applies also to CSS, is that we've seen some websites actually hard code HTTP resources on secure pages. That's a problem. And the reason for that is twofold, because sometimes browsers will block insecure resources from being downloaded, so your web page will not work as you intended. And the other thing is that if the browser doesn't block that download, and actually downloads it insecurely, you're opening up a security hole in your website for your users. So fixing that is very, very important. And the other thing is that it's one of those inconsistencies that we can pick up on in our indexing. If we see that a secure website doesn't quite know what it's doing with the page resources, we might be indexing your website inconsistently.
So Pierre, just to clarify,
yeah.
that / kind of looks weird. Is that correct syntax?
That's actually a good point. So look at this. Who knows relative URLs here? You've all done it. This is a special kind of relative URL. It's a protocol relative URL. Now, we're all developers here, and we all develop on our own workstations. When you have this, that means you can actually develop and test your website as you're building it without having the certificates installed on your server locally. Okay, so when you have it this way, it will work on your development machine, and when you deploy it live, it will actually be secure and use the server configuration.
Right. So if the page is rendered on a non-secure origin, that will just say, well, I want to load the unencrypted version of script.js.
Exactly. Right. So the other thing that we see is that sometimes we have a secure web page, but then it has a hard-coded HTTP link to other links to other pages on the same website. So again, this is an inconsistent one, okay? You're securing this page, but you're linking to the insecure page, and we'll talk about why that's bad, because it will incur redirects and it will hurt performance, but also it's something that our algorithms can pick up on. If you're being inconsistent about how you're linking, it might actually be a problem for us. And again, if you use the protocol relative URLs, it's actually useful for you when you're developing. So these are the basics. This is the answer about how you can get your secure website indexed. If you know about how this works, there's nothing magical about it. It simply is 2 steps. The first one is that you make sure that any insecure URLs redirect to the secure counterparts, okay? And you use that with a 301 redirect. And the other thing is that you emphasize that signal to our algorithms by having a rel canonical on the page itself, the secure page itself. The rel canonical will point to the page itself. So it's a self-referencing rel canonical, which emphasizes the signal that you're sending us with the redirect, okay? And remember here, both Googlebot and the users are getting this redirect. Treat them the same way, and everything will be fine. Redirects are very, very important, okay? Because that means when the page is being shared, when it's being emailed, when it's being bookmarked, that it's the secure version of the page that is being used here. The other thing is that the redirect is an important signal for our algorithms that says, don't index the insecure URL, index the secure URL, okay? And again, treat Googlebot and users in the same way.
Right, and this is also important because chances are you've had your content linked by many other sites, and you want to make sure that those links, or the users that are following those links, end up on the secure version, which is, once again, why redirects are so important.
Exactly, and this is especially true for established websites. It's easier when you're starting from scratch, being secure, but established websites that are migrating, that will not be the case, okay? Here's the other thing. There's a tip for redirects. We've seen this, and I was personally guilty of this, is that sometimes we see the insecure redirects go in a chain. So in this example here, so the insecure, the HTTP URL without the subdomain www actually redirects to the insecure www subdomain, which in turn redirects to the secure version of that. That's extra latency for your users. If browsers and Googlebot are okay with short redirect chains, that's fine, but you're actually you're incurring extra latency for your users. What do you do about this? You already know the answer. You know where they're going to end up in, okay? So just send them there directly, and then you don't incur any extra latency. And this is doubly important, especially for your mobile users.
Right, and I was actually just going to say, for mobile users is where I actually find this to be the most, or the biggest problem, because you end up with the mobile redirect that goes to the first, you have the domain that goes to the mobile site that then takes you to the HTTPS site, right? And this is extremely expensive, especially in mobile, because the latency is so high. So I have one tip for you guys that would actually help you eliminate a lot of that latency, and that's HSTS, or the HTTP Strict Transport Security. So this is a header that your server can return when it returns the page, which actually sets a policy on the browser. And it consists of 2 parts. First, there's the max age, and then there's the include subdomains. The max age basically says, remember this policy for this amount of seconds. So this is just like a caching header. And include subdomains does exactly what it implies. It just means that also apply this policy to subdomains. When this policy is set, the browser will remember that you want this site to be accessed over HTTPS. And every time the user tries to request your site, it will automatically take them to the HTTPS site. So it will actually skip that redirect. It will apply that rewrite on the client before it even sends the request. So this is important for performance because obviously it eliminates the redirects, which is what Pierre is describing, but also it eliminates an entire class of downgrade attacks against your user. So those two things combined is what makes HSTS so important.
Yep, and not just that. I mean, serving HSTS is another signal that our algorithms can potentially look to see that you actually really, really want us to index the secure page.
Right.
So here's the other thing. So those class of the signals we've talked about now are kind of visible to users. Now, redirects for Googlebot obeys the robot exclusion protocol, which in this case, we're talking about the robots.txt file. You could actually be, because browsers don't look at the robots.txt file, you could actually be inadvertently blocking Googlebot from accessing either or both of your insecure and secure website, okay? These are directives. Now, so we would follow them once we discover those rules that says do not access this, the secure or insecure page. This can lead to serious inconsistencies about the indexing of your website. So the first thing to look at is whether Googlebot is allowed to crawl both the insecure and the secure URL. So that means we are able to discover the redirect and also index the secure content, okay? And you can use that with, in Webmaster Tools, there's a tool called Fetch as Google, and if you give it a URL, it will tell you whether Googlebot is able to access it or not and what the content that is returned. Okay, so that's the first problem you need to check at. The other thing is that suppose you've done all this and you've allowed Googlebot to crawl the pages. We've seen webmasters inadvertently add a no index that directs us to not index the secure page. So they've got us to crawl it, and then they say don't index it. Now, you can do there are two ways to put a no index. You can do it either in the HTML, and you can do it either as an HTTP header. This is what they look like. Remember, this is not what you want to be doing if you want the page indexed, okay? So don't copy and paste this. This is what you need to be looking for to make sure that it's not there on the page. And again, you can use Fetch as Google in Webmaster Tools to see if that HTML or the HTTP header is being returned, okay? Now, the other thing is that the rel canonical. We've talked about that, and we've seen inconsistencies again, where the secure page, although it redirects and everything, it will actually say the rel canonical has links to, references the insecure counterpart. So it references the HTTP version of the URL. And the problem with this is that A, it's an inconsistency and can lead us to index your content inconsistently. Okay, but also if you do it right, it emphasizes the signal that you're already sending with the redirect.
Right, so what I found when I was migrating my site is I had to audit both my past content, right? Because I had examples of where I hard-coded HTTP links, I had hard-coded HTTP resources in other places. And you mentioned Fetch as Googlebot, right? Yes. So using Webmaster Tools was actually very helpful to find these problems. And I know that you guys have been working on a lot of awesome stuff to improve it.
Yeah, so thank you. Webmaster Tools is a developer's friend. Use it. The way it works is that you verify ownership of your website. And once you verify ownership, we share with you data that you don't want others to know, like indexing and ranking information about your website. It has a ton of features. I'm not going to go through all of them, okay? So please verify your sites and start exploring. For secure websites in particular, I'd like to highlight a couple of things and give you a couple of tips. So let's dig in for here. The first thing is that I would like you to verify all variants of your websites, and we'll talk about what that means in a second. There's also two reports that you need to be checking. One is called index status, and one is called crawl errors. What are these? Let's start with verifying all versions of your websites. Now, these four here that I've listed, the HTTP, HTTPS, and www, and without the www, are treated as different sites. Now, if you're doing things correctly, you're redirecting to just the one version. Okay? But you need to verify all of them, because what we've seen sometimes is that the protocol and subdomain, the protocol and host name combination can actually have different problems. And you wouldn't know about that unless you keep checking all of them separately. Okay? So verify all of them. And yes, by all means, check the canonical version most, because that's what your users are interacting with, and that's where you're redirecting everyone. But keep an eye on the other ones.
So this is actually very important. I just want to highlight this one because this is something that caught me off guard as well. Yes. I didn't realize that each of these sites is a different one. So when I migrated my content, it seemed like you'll see this in the next slide. You see my kind of indexing go down. I was like, oh my God, I broke the web. And turns out that I just needed to add that the other profile, and I saw everything spike up. So it's a different profile. And
speaking of different profiles, lots of websites have a separate mobile URL, separate sites. While you're doing all these verifications, make sure you also verify the mobile site, because again, it's a different one, and just to see if there are any problems with that. Now, this is what Elia was talking about. This is the index status report, and these are actually two separate reports. I took them from the same website, okay? And what you can see is that this is the basic report. Index status has basic and advanced. And what index status does is that it tells you about the number of URLs we know and the number of URLs that have been indexed, okay? Historically, that wasn't the best report, so we've improved it recently, and you see that still in the graph. There's the vertical line that says update. Now, on the left is the insecure version, the HTTP profile of the site. Notice that we've historically said it's been, there are lots of like 10, 15 pages indexed, and then it drops to 0. What's happened in this site is that the site has moved to the HTTPS version quite a while back, but Webmaster Tools wasn't reporting it. And so when we did that update and started reporting the data accurately, that says this is not, you're looking at the HTTP URLs instead of the HTTPS URLs, okay, well, the indexing dropped. And this is what you want, because if you're doing everything right by telling us that you want to index, we should index the secure website, and if you've given us enough time to, for the algorithms to update the indexing, the insecure site has to flatline. Okay? You want this insecure website to go to 0 and not have a heart attack like Ilya did. Okay? But what you want to look at is the secure version of the site and see that the pages are being indexed.
And chances are, if it's not flatlining, then you're probably missing a few redirects or other things that you should hunt down and fix.
Yeah. Or actually, a common one is also robots.txt blocks, so we actually don't know that there's a redirect.
Right.
Okay? And this is why you need to verify both of them and see if there's a problem or not. Similarly, we have something called crawl errors. And just like index status, keep checking and see if there are any problems that you don't expect. If you see that the host name and the protocol combinations, there's something unexpected going on. We break it into site-wide and URL-specific ones, and we have smartphone and desktop specific errors. So again, something to keep an eye on. And the last thing is, a couple of weeks ago, we massively improved our documentation for how to move a website. And a move to secure websites from insecure websites is a site move. It's a type of site move. And so I'm not going to go through the recommendations right now. If you follow that link, or if you just search for making site moves easier, you'll find this documentation, and it's very, very detailed about all the things you need to be thinking about when you're migrating to secure URLs. It covers a lot of the stuff we've talked about and quite a bit more. So in summary.
Yeah, and that resource is actually very, very good. It helped me quite a bit when I was migrating my site. So we talked about a lot in the session. So just a quick recap. When we talk about TLS, really we're talking about encryption, authentication, and data integrity. TLS is not slow, right? We've talked about a lot of things that we can do to optimize it. And TLS can actually be used to make your sites both faster and your operations actually use fewer resources. So that's all important. We should be using HTTPS on all sites, HTTPS everywhere, right? That is our message here. And there is some work that you guys need to do to update your content. You need to audit your content, fix mixed content, fix your links, and other things, and make sure that you're sending the right signals. Webmaster Tools, Qualys, and there's all this infrastructure that is already in place that is available to you guys to make this work.
Right. And there's more here at I/O. Tomorrow, there's a talk at 3 p.m. about how we deploy security at large scale at Google. So if you're interested in doing this and see our experience, please come to that. And also, at 3:30 p.m. tomorrow, we're doing a sandbox session. I think it's on level 2 here, to talk about some common mistakes and talk about if you have any SEO questions, which covers some of this. You can also come and find us, ask us questions, and we'd love to have your feedback, please. If you scan this QR code, it will take you straight to the feedback form, or you can just follow that link. And thank you for coming. We have a few minutes. If you have any questions, you can ask us now, or you can come afterwards. Can you actually go to the microphone? If you go to the microphone and then ask.
Is there any talk that would cover blacklisting of certificates, specifically in Android?
Do you know that?
Can you elaborate on that?
Well, I believe since Jelly Bean, there is a facility to blacklist CA and EE certificates in Android.
So I'm not familiar with the exact process in Android for blacklisting. There are things in TLS, things like revocation checks, and that are used to revoke bad certificates. I'm not sure about denying access to the entire CA. If you want, we can follow up later.
Eric, do you know the answer, Eric? Oh.
Yes, in general, one thing that we might add to the recommendations there is to do OCSP stapling, because online certificate revocation is not reliable. So what we do at Google is push out changes directly to Chrome or to Android to try to blacklist some very particular famous certificates that are actively being misused in the wild.
Yep.
Thank you.
Yeah, what about those of us who make our money through advertising and therefore may have some significant remnant advertising that we can't control that's coming through a DSP or something like that, and therefore lose a lot of money?
That's a great question. So, I mean, this is something we care about quite a bit at Google. And
you guys have the
and the AdSense team has actually enabled, there's an ad unit that works now with secure pages. So you can use AdSense for those pages. And I think more and more networks are starting to support secure pages, advertising on secure pages.
Yeah, but I think what the best policies should be to have your advertisers make sure they do support secure pages.
That's the other thing, is that if you're not using an ad network, if you're talking to advertisers directly, make sure that their infrastructure supports that, because otherwise you'd be including an insecure JavaScript ad unit.
Or a DSP.
Yeah, and then that won't work, or it might not give you the results you're looking for.
Right, but just to highlight what Pierre said, there is now an ad code that you can install which is TLS friendly, which was not the case before. So that was released earlier this year, so please take a look at that.
Hi, so I've got a large site with millions of pages, and out of fear of a search traffic catastrophe, I've kind of decided to move just a small fraction of the pages at a time to SSL, but I believe the recommendations say to move the whole site at once.
Yes.
And I was wondering if you can comment on that. Is this a bad approach? I kind of don't want to do all this at once and all of a sudden find out there's no crawling happening, or I've made a huge mistake and I'm losing money every day.
So this goes back to the fear and uncertainty that webmasters go through, and I agree with you. Now, the best thing to do is actually, bite the bullet and jump in, okay? Do it all in one go. Now, before you do that, of course, you need to set up and make sure that the infrastructure does exactly what you need to do. So if you look at the recommendations, they'll say set up a separate copy and test that properly, okay? And make sure that everything is working on that before you move. But once you move, we've seen some really badly implemented site moves that way, that when you move pieces at a time, that doesn't quite work out as you intended.
Can you explain why that is?
There are quite a few edge cases. So, like, to go back to the example where you would have, for example, if you use the protocol relative URLs to link to other content on your site, if you're on a secure page, you're actually linking to the secure another page that's secure. But if you're not serving that already as secure, you're basically sending them to a page that's is supposed to be secure but isn't, and the browser can throw an error or something like that.
Right. Well, so in my case, I will have an excess volume of 301 redirects. I'll have more 301 redirects than I think I would like, but I'm kind of weighing that against the fear.
So that's the thing, is that if you follow the guidelines, the recommendations, and if you have any questions about them, please come to our forums. And we also have webmaster office hours. You can come and join and ask questions directly. And don't have the fear. Just make sure that you follow the guidelines and make sure you follow all the steps. What Ilya was saying, make sure you think about every step that has been highlighted, and you should be fine.
Okay, thanks.
Yeah, good luck.
I imagine that you need to change or have both HTTP and HTTPS in your sitemap.xml or XML.
No, you'd need only the HTTPS. So does everybody know what a sitemap is here, by the way? Yeah? Okay, so a sitemap is basically exactly what it says. It's like, here's a list of links, URLs that are on my site. What we recommend is actually have just the one version, which is the secure version of your site in the sitemaps. Now, during the transition, it's okay to actually have an HTTP one, just produce one, and to monitor indexing. Because if you look at the recommendations, we report a number of URLs that are indexed for each sitemap. So if you have the HTTP one, you would start with like 100% index, and you want it over time to drop to 0. And if there are still ones that are still indexed, it would be good to look at why they're still indexed and what's going on there. So during the transition, it's okay to have both, but in the long run, you'd want to move to just HTTPS URLs.
Once it flatlines, then
yeah,
get rid of all
and that's the thing, is like, you don't need sitemaps. So if you want to skip the monitoring using sitemaps with insecure URLs, that's also perfectly fine. So by all means, go ahead and just submit sitemaps with HTTPS URLs only, and you'll be good.
Thank you. And just to be clear, I would intend to do this. We switch over to HTTPS in the canonicals,
yes,
and we set up the 301s. we're going to retain all our indexing in Google
Yes.
search?
Yep. So it's a per URL process. It's an organic process for each URL. So it's not like the site will move, millions of pages in one go. It's as we process, as we crawl and process each URL. So it will be, it's a move over time. It's not like everything moves in one go. So you won't lose, the indexing signals will be consolidated and everything. So if you do that correctly, you'll be fine. Okay?
Right.
You might see a bit of hiccuping, but you shouldn't be worried about that.
Thank you.
So I think we're almost out of time, so maybe just one
Yeah,
more.
last question, please.
Hi, so I just wanted to know that do you guys have any suggestions for older browsers? Is there something, like for instance, Android 236 browser does not let you install demo certificates and stuff like that, so is there anything I can do for that?
I'm not sure about installing the certificates. I thought you were going to ask about things like SNI. So if you need to support older clients, you will need a dedicated IP address. That's something that you need to look into. So if you're targeting older browsers. But I do believe there's a way to load, like if you need to test, you can load and whitelist certificates on Android, even on the older versions.
Okay, cool. All right, thanks.
Cool. Thank you, guys.